Today we will hear from Christine So, who is the Subsea Submarine Sales Engineering Consultant at Ciena. She will provide you with insight into unlocking the power of repeaterless subsea systems. So today, during the call, Christine will discuss how CNL band technology extends to the limits of the repeaterless subsea design, the role of the MPB Raman solutions in boosting the performance and reach, the CapEx and the OpEx comparison from the repeaterless versus on the repeater systems, maximizing design capacity and system reliabilities. So during this call, the recording, we will let you know that we are recording today's section, and the recording will be made available on ciena.com shortly after the section. So in terms of the questions, Christine will be happy to address the Q&A at the end of the presentation. Please post your questions in the meeting chat. We will be looking at that one right after the presentation. So there will be a mix of the organizations on the call. So if anything that you do not want to ask in an open forum, or anything after that you want to talk about that, and please send through to us, and we will get back to you in terms of the answers and the response you're looking for. I will pass it to Christine, and thank you for everyone.
Thanks, Isaac. Hi, good morning, everyone. My name is Christine. I'm part of Ciena Asia Pac Subsea Engineering team based in Malaysia. I will be sharing on the topic repeaterless subsea system today, covering its design, its capabilities, and how can we extend the design capacity using CNL band, and also the commercial benefits of repeaterless subsea system. So today I'll be covering 6 of these main points, starting off with the difference between repeated and unrepeated system. We'll talk about its design, and then we will look into what amplification is required when we use the unrepeated system. For example, we have the option between Ciena's Raman amplifier, which we call the SRA. We also have the option to use the MPB Raman, which is a third-party vendor Raman amplifier, and how it integrates seamlessly with Ciena 6500 of RLS photonic system. And the next point, we'll talk about something more interesting when we talk about the dollars and cents. How much savings are we actually talking about when we compare repeated and unrepeated system? Last but not least, I'll conclude with some guidelines on how to estimate the maximum achievable capacity depending on the reach. We'll end with some key takeaways at the end of the session. And I promise that I will not take up the full 1 hour slot, so please stay with me till the end. So let's start off with some key differences between repeated and unrepeated systems. So here we have a diagram that shows all the equipment required in a repeated system. So on the left side here, we have the dry segment consisting of the point of presence, the POP site, and also the cable landing station, the CLS. So we'll find the network management system that will help us to monitor and control the operations of the overall network. And in the cable landing station, we will find key equipment such as the submarine line terminal equipment, the SLT. And then we will have the power feeding equipment as well. So this power feeding equipment actually powers up the repeaters that are deployed in the wet segment. As you can see, the repeaters are placed at almost equal distances undersea, and we will need to power them up using the PFE. So this PFE actually conducts like a very high voltage and constant current through the copper conductor. And for this undersea repeated cables, we will need a supervisory equipment, or commonly known as the line monitoring equipment, the LME. So, and in order to have repeaters undersea, we will need some kind of a specialized installation vessel to deploy those repeaters. So what happens when we transform this repeated to unrepeated system? So as you can see, the number of key equipments have reduced. We have removed the repeaters from the wet segment, and as there are no repeaters, we no longer require the power feeding equipment. We don't need the supervisory equipment, and the vessel, we no longer need the complex specialized installation vessel. So overall, with unrepeated system, we can reduce the cost, and also we can simplify the operation and the deployment as well. So here is a more detailed table of the differences between these two systems. So I'll just go through it briefly. When we talk about repeated system, we usually refer it to about thousands of kilometers. So I think we are very familiar with trans-Pacific cables extending up to 10,000 kilometers, whereas unrepeated is usually about 500 kilometers or less. Repeated cable have more equipment, so it's a little bit more complex. We have the PFE, the power feeding equipment. We have the monitoring equipment in addition. And of course, with repeated cable, we have the repeaters that needs electrical power. In terms of the number of fibers that we can fit into the cable, for unrepeated, we can actually have more fiber pairs compared to repeated cables. And the effective area of the fiber for repeated cable, we usually use a wider or a bigger effective area of the fiber. In terms of capacity, so for unrepeated cable, I think we're all aware there are some limitations to the capacity, the maximum capacity for unrepeated cable. So because there are no repeaters, right? So it really depends highly on the distance and also the fiber type. And in terms of the suppliers for repeated cable, we have just about a handful of wet plant suppliers for repeated cable. I think we can name them all. Whereas for unrepeated, we do have more choices in terms of suppliers. We need copper conductor to transmit power for the repeaters. And of course, the operation will be more complex and it is more expensive. And to deploy a repeated cable, it takes longer time compared to unrepeated. So in a nutshell, what we're trying to say is that unrepeated is the simpler and cheaper choice when the distance allows it, of course. In terms of equipment, it is less. In terms of the cable type and fiber count, we can have more in the cable as well. We don't need the copper conductor. And in terms of the installation vessel, we can use some kind of like a barge style vessel instead of the specialized one to deploy the repeaters undersea. So let's move to the second point where we'll talk about the unrepeated system design. So here are the different types of unrepeated system. So we'll start off with the most common one, which we call the island connections. So this design is to connect a small island to another small island, or even from a small island to the mainland. So a lot of island nations actually rely on this kind of connection for their primary international network. We also have the oil rig connections, as shown here. So the repeaterless cable will actually allow connectivity between the offshore oil rigs, the offshore platforms, to the inshore facilities. And we also have another type which we call the island festoon. So this is where we have like multiple of islands linked together in a chain. So that's why we call it festoon, as it's linked up together in a chain. And we also have what we call the coastal festoon, where the link is along the coastlines, linking several coastal landing points. So here is to show that unrepeated cable system comes in different types, and this technology can actually be applied on terrestrial system in order to increase the maximum reach and to skip unnecessary huts. So let's now look at the key parameters on how do we design an unrepeated system. So there are four main considerations here, starting off with the fiber itself. So the two main factors contributing to the fiber parameters that are very important is actually the fiber loss or attenuation and its core size. So the core size will actually determine how much light that can be transmitted into the fiber, and choosing the right fiber with low attenuation and optimal core size is basically the main fundamental factor that will help us to extend the reach of an unrepeated system. So once we have set the fiber, the next question is capacity. So how much do we need? The required capacity that we would like to have on the cable actually will dictate how aggressive this fiber performance needs to be, what modulation format that we need to use to achieve that capacity requirement. The third parameter is margins. So in subsea cable system, we always talk about, we always need safety buffers to account for things like aging, repair splices, and even unexpected losses. So with adequate margins, right, we can ensure that this unrepeated system will maintain its reliability, that it can perform over the next 20 to 25 years. So that's a really long time. So with all of these factors taking into account, that will help us to choose the right amplifier and in order to achieve the highest line rate for your system. So for example, in terms of choice, you have the choice between, let's say you can deploy a terminal EDFA only, or you can even consider to deploy Raman amplifiers, or even both. So by taking into account all of these key parameters, it will help us to ensure that our unrepeated cable will actually work. So now let's explore how unrepeated system is designed and configured. So in this chart, I'll be showing three main designs. So the designs will actually be depending on the transmission distance and the span loss. So you will see that the three different designs will have progressively increasing distance and span loss. So starting off at the most basic level, we call it the baseline. We can design a system by just using the EDFA only. So here the terminal erbium doped fiber amplifier will have enough launch power to support spans up to 40 dB span loss, or roughly under 200 kilometer distance. So as you can see, this configuration is very simple. It's straightforward, cost effective, and it is widely used actually for short distance connectivity. But as you can see, the range is limited. It's limited to below 200 kilometers. So if you have a system that has longer distance, then we will definitely need more advanced options. So here comes the second option, where we add a Raman amplifier. So this Raman pump here will help us to boost the signal power, and it will help us to support higher span loss up to 45 dB. So even in terms of the transmission distance, we can go up to 250 kilometers, or even in certain cases with this Raman, we can extend up to 270 kilometers. So this is actually very useful when we want to extend the connectivity by with just only applying the EDFA. And also, fun fact, Ciena has our very own in-house Raman amplifier, which is called the single line Raman amplifier, the SRA. So this is Ciena's Raman amplifier shown here. And we are actually able to offer this configuration for your unrepeated system design. And the third option is the MPB Raman. So this MPB Raman is actually a third-party vendor. It's basically higher power Raman compared to the SRA. So as you can see, this MPB Raman, it can support multiple configurations, which we will talk about later during the sharing. And this MPB Raman will actually extend the reach significantly. So as you can see, Even in terms of distance, we can go beyond 400 kilometers. And in terms of the span loss that is supported, we can go up to 80 dB. So that is really a game changer in terms of the unrepeated cable system. So even with MPB Raman, we can add the roper in the middle. So with roper support, we can achieve the distance of beyond 400 kilometers. And we are talking about the roper being installed. It's about 100 kilometers. So as you can see, the roper here, which is the remote optically pumped amplifier, which is installed about 100 kilometers from the receiving end here. And this allows us to further boost the signal without adding any repeaters. So this roper is actually being powered by the Raman at the terminal. So we don't need any electrical power for the undersea equipment. So in summary, if you have a very simple short distance, you can choose the EDFA amplifier option. If you have a little bit more challenging segment, you need to support up to 45 dB span loss, we can consider to deploy the Ciena Raman amplifier. And if you have the even more challenging ones, up to 80 dB span loss, then we can consider the MPB Raman, which is the higher powered Raman. So how do we choose which amplifier to deploy? It really depends on the distance, the span loss that you need to cover. So let's look into more detail on what is this Ciena's Raman amplifier. So this single line Raman amplifier will extend the reach of unrepeated cable system. So this single line Raman amplifier, or we call it short SRA, it's actually a counter pump. As you can see, this Raman pump is actually placed near the receiving end. And what it means is that this Raman amplifier transmits light in the opposite direction of the traffic signal. And the optical gain is actually, it depends on the fiber properties and the SRA pump power. So when we talk about the optical gain, we usually, on a standard fiber, we can assume of approximately 0 to 22 dB gain by just using this Raman amplifier. So you can see on the right here, this is the Ciena Raman amplifier. As you can see, it's just one physical card. It's not a huge equipment. It's only a single card that can be installed in Ciena 6500 chassis. So that means you don't need a completely new platform for a Raman amplifier. It can be accommodated in existing shelves as well. And most importantly, an important fact is that this Ciena Raman amplifier is CNL band. So it works on CNL band. So let's look at the graph below here. As you can see, there is a blue line. So this blue line shows what happens when we don't have the Raman amplifier. You can see that the signal performance is degrading continuously with the distance. And we have about negative 35 dBm at the end of the span. So the pink line shows what happens when we add the counter Raman. So you can see that there is a booster towards the end of the span, having a 10 dB on-off gain. So with this Raman amplifier, this SRA, we can, basically it's a clever way to push the reach and the span loss that is supported without adding repeaters. So we have covered Ciena's Raman. Now let's talk about the higher powered one, the third-party vendor by MPB. So here I would like to highlight the important partnership between Ciena and MPB Raman. So MPB has a patented Super Raman technology. It is based on a third-order pumping techniques. It is a key enabling technology for the unrepeated system. So what it does is actually, it will help us to extend the reach, the distance, and increase the number of channels supported in your unrepeated system. So the partnership between Ciena and MPB goes way back, even up to in 2008. So since then, Ciena has contributed our strength as the SLTE market leader and MPB as the leading supplier for Raman amplifiers. So we don't just collaborate in terms of products, we even collaborate in terms of system design. We have worked together on building designs together. We even have a complete test bed in our lab in Ottawa using real MPB Raman amplifiers to validate real-world system performance. And not to mention that, of course, the MPB amplifiers, even though they are from the third-party vendor, it can be integrated seamlessly with Ciena's Photonics 6500 or RLS, and even in our network management system called Navigator. So in terms of experience, we have extensively deployed MPB Raman amplifiers over more than 600 units, including in unrepeated submarine, in ROPA systems. We have also deployed these MPB Ramans in terrestrial networks for long spans, and applicable for both greenfield or dark fiber and upgrades. So let's see what configurations are supported by MPB high-powered Raman. So starting off from the first one, so as you can see, right, the options here is that in order to support higher span losses and higher distances, obviously the amplification will be adding more amplification basically. So starting off from the counter Raman, as we have a Raman that sends light in the opposite direction of the signal, and this counter Raman can operate at the pump power of 1.5, 3, or 5 watt, and this can support the span loss of up to 60 dB. So if we want to support higher span loss up to 70 dB, then we add another co-propagating Raman. So here we are having a dual pumping. We have two pumps here at the transmit and at the receive. And if we want to, even to be more flexible, you want to extend your distance, then the other option is by adding the ROPA, which is the remote optically pump amplifier. So as mentioned, this ROPA does not need any electrical power for the undersea equipment. It's actually being supported by this counter-propagating Raman amplifier. So here's to show that you do have options, you do have flexibility on what amplifiers to use for your unrepeated system in order to support this span loss or to support the extensive distance of your unrepeated system. So if we look more in depth in all that three options, starting off with the counter Raman, this counter Raman can support up to 60 dB span loss. So let's look at the graph below. On the vertical axis, we have the optical power, and the horizontal axis, we have the transmission distance. So here you can see there are two dotted lines. So the first dotted line at the top, it represents this non-linear limitation. So when the optical power gets too high, then the fiber non-linear effects will affect the signal performance. So we wouldn't want that. And at the bottom, we have the noise limitation. So if the signal power gets too low, then the noise will dominate and the OSNR will become unacceptable. So in the red line, it shows the signal power profile. As you can see, the signal will degrade with the distance. And towards the receiving end, we have the Raman boost, the Raman gain from the counter propagating Raman that ensure that this signal power stays in between these two dotted lines. So basically, we wouldn't want to exceed the limitations on the nonlinear effects and the noise. So with co-counter, so when we add a co-propagating one here, as you can see, the signal profile here, it shows a better performance at the beginning. And of course, the signal will continue to degrade. And then we have an additional booster with the counter propagating. So here is to show that when we have dual pumping, it will create a much more balanced signal power profile compared to just having one single counter Raman only. So this is capable to support higher span loss up to 70 dB. So if you have even more challenging unrepeated system, like beyond 70 dB, then that's when you will add a ROPA in the middle. So with the ROPA, we are able to support up to 80 dB span loss. So this is actually equivalent of the longest practical distance that we can support in unrepeated systems today. So this signal power profile, you can see in the clear boost from the ROPA, that power remains above the noise limitation. So of course, when you combine all these three, right, you have the core, you have the counter propagating, you have the ROPA, all these three will basically is the most powerful unrepeated design option, and it will allow you to go even beyond 400 kilometers of distance. So the remote optical pump amplifier, the vendor we're talking about here is MPV. They provide the erbium fiber cassette. And with the ROPA, we can enjoy higher gain for long spans. We don't need any dedicated pump fiber for this ROPA. It can be integrated into different manufacturer splice boxes. So you can see in this picture here is an example of the ROPA in the middle here that is being housed in the same cassette as the cable, same box as the cable manufacturer, which is NSW here, as an example. And the ROPA can support up to 24 fiber pairs. So it's a very powerful solution for unrepeated systems. So as we talk about MPB Raman as being the higher powered Raman, the most powerful one, so it's coming from a third-party vendor. However, it integrates seamlessly with Ciena's 6500 or reconfigurable line system, the RLS photonics. As you can see on the right-hand side here, this is the rack where we are installing the Ciena photonics shelf at the top. And at the bottom, we can just stack it together, the MPB Raman with Ciena's photonics. So you can see that it can be accommodated within the same rack. Take too much space. The MPB unit per unit takes up about 2 rack units, and each MPB Raman will of course require a fan unit for the cooling. And in this diagram is just to show the integration of the Ciena 6500 amplifiers, the MLAs, and it's connected through the splice connectivity connection here to accommodate the MPB Raman amplifiers in the system. So not just in terms of infrastructure or in terms of the cable landing station, we will also need to monitor those MPB Raman amplifiers, and it can be integrated seamlessly into Ciena's network management system called Navigator. So there are all these key features that you will be able to enjoy even if you're using a third-party Raman amplifier. You will have access to a webcraft interface where you can view the Ramans that are being installed in the network with its connectivity status, and even in terms of managing its alarms. And so what we're trying to say here is that with MPB Raman, it can be integrated in our network management system. We can have a simpler and a faster, network operations day to day. So we have covered Ciena's Raman amplifier, Ciena's in-house Raman called SRA. Then we have also seen the configuration of MPB Raman, which MPB Raman is the higher powered Ramans. So let's try to bring these two choices into a real world example. So in this example, we have a repeaterless system of about 266 kilometers and a fiber loss of 46.54 dB. So it's pretty challenging link. And even in terms of fiber loss is pretty high. So we have done a network simulation. And so the question here is, should we use Ciena Raman amplifier, or should we use the higher powered MPB Raman? So here is the results of the network simulation that we have done with these parameters. So in this column, we are comparing Ciena Raman amplifier, and this is MPB Raman. So as you can see, in terms of the photonics, it can work on the same photonic system of the Ciena RLS. And a very key differentiator here is that Ciena Raman amplifier can support CNL band, whereas MPB Raman only supports C band. But as mentioned, right, MPB Raman generates higher power Raman amplification. So in terms of line rate, it shows better performance. We can achieve 1 tera, whereas for Ciena's Raman amplifier, it's a mix of 500, 600, 700, 800 gig. However, in terms of design capacity, as you can see, the clear winner here is by using Ciena's Raman amplifier. The reason why is because of we can basically have double of the capacity with the CNL band. So an additional of like 7 tera of capacity. In terms of power, it's more than double with MPB Raman. In terms of space, definitely MPB Raman in this scenario takes more space in the rack. And in terms of the cost, when we compare the cost of the amplifier, it's 5 times more actually when we compare MPB with Ciena's Raman amplifier. However, Ciena Raman amplifier, it has some limitation. So it supports the span loss of up to 50 dB only. So if you do have more challenging segment, then MPB Raman will be the recommended approach. So obviously for this real world example, the Ciena Raman amplifier seems to be the better choice, as you can enjoy higher capacity at lower cost. However, the answer here is not to say that Ciena Raman amplifier is the only solution, the only best solution. There is no one solution that fits all. So even as SRA can offer a simpler and lower cost design, but when we have a more challenging segment of, say, a span loss of up to 80 dB or such, then you will need to use the MPB Raman to extend your reach and to achieve higher performance. Okay. So now let's talk about something more interesting when we talk about, the financial aspects of this repeated and unrepeated system. So usually when we want to talk about savings, sometimes we only focus a lot on the CapEx, on the project budget, on how much it will actually cost to deploy a repeated system. But often we neglect the cost of the OpEx. And as we all know, submarine cable, when we deploy them, we will hope that it will work for the next 20 to 25 years. So OpEx over those long years will actually be quite a significant number. So for this high-level comparison, we have taken these 2 factors into account. So for the CapEx, we have listed down the main items here. For example, in repeated cable, we have additional repeaters, we have the power feeding equipment that will cost more. In terms of the submarine cable and installation, we will need to deploy those specialized vessels, so it will cost more. It takes longer time to deploy them as well. In terms of terminal equipment, for unrepeated, it will show higher costs because we will be installing Raman amplifiers. And for testing and commissioning, for unrepeated, it will be much simpler and faster. So as you can see, the values here are not in millions of dollars. We have normalized this cost with the baseline of 100 for the total CapEx of unrepeated. So in summary, it shows 42% lower CapEx for unrepeated system compared to repeated system. Now, if you were to compare OpEx, so OpEx, there are many sub-items, so we only listed the main ones, like power. You will definitely need more power with the PFE, LME. We take into account the maintenance and repairs. How many times in a year do we need to deploy the repair vessels in case of any faults of the repeaters? Monitoring personnel and also some miscellaneous O&M costs, such as the spares of the repeaters and the PFEs. So of course, these values, as you can see, it's a huge number, huge difference, as we have taken into account the whole system life of 25 years. So we're talking about 83% lower. when we compare these two. So if we take the CapEx plus the OpEx, we are talking about 75% lower cost for unrepeated system. So we have reached the final point with some guidelines on the maximum achievable capacity depending on the reach. So we have a graph here where we have the capacity versus span loss. So this result is to note that actually this is using WaveLogic 5E numbers, which is Ciena's 5th generation transponders. And I'm sure you all have heard and known or probably have installed Ciena's latest and greatest WaveLogic 6E. So the numbers for WaveLogic 6E will be available by early of next month, as we are finalizing the numbers in our test lab. So here, just as a reference, as you can see, we can achieve almost 13 tera capacity per fiber pair for span loss up to 59 dB. So that's pretty good by using MPB Raman. However, if let's say you see from 59 to 61 dB, so that's only a difference of 2 dB span loss, we can see a quite deep slope, a quite deep descent in terms of capacity, almost at 8.5 tera. So we lose a lot of capacity by just adding 2 dB span loss here. So in summary, what we're trying to say here is that in unrepeated system, the design capacity depends very importantly on the distance and span loss. So even in a 2 dB difference, the capacity gap is pretty huge. So by using the right fiber with low attenuation, optimal core size is very important. And if we want to further improve the capacity or higher capacity, there is an option to add the ROPA. So when we add the ROPA, we can maintain the maximum capacity of almost at 13 tera. And previously it was 59 dB span loss. Now we have extended it up to 67 dB. So 59 to 67 dB is a huge extension as well. And as mentioned, even in the difference of 2 dB, so 67 to 69 dB of span loss, the difference of capacity is pretty huge. So I hope this provides some guideline in terms of estimating the capacity for your network by using the MPB Raman. So I would like to conclude with some key takeaways. So the first conclusion is that unrepeated is the simpler choice, of course, when the distance allows it. Reason why is because it uses less equipment, it takes faster time to deploy, and of course, it's cheaper. Second, for unrepeated system, you have multiple configurations to choose from. It is flexible. You can use the terminal EDFA. You can choose to use the Ciena's Raman amplifier or even a higher powered one, the MPB Raman. And even within MPB Raman option, you have the counter Raman, the core plus counter Raman, and also you can choose to deploy a ROPA. And even if you use an MPB Raman in your network, we can ensure that Ciena and MPB is your best and trusted advisor when it comes to designing your unrepeated system in order to estimate, your highest capacity achievable with your certain reach and span loss. So please feel free to contact us anytime if you have a new unrepeated cable system to design, you need to choose or you need to have some estimates on what amplifiers to use. You can definitely approach any one of us from Ciena, as by choosing the right transmission equipment and amplifier will guarantee your system to achieve extensive reach and to ensure high capacity at a good cost. So with that, I would like to conclude my sharing, and thank you so much for your time and attention. So yep, I didn't take up the full 1 hour. Thank you.
Thank you, Christine. I think this is a fantastic presentation, and I hope everyone captured that. So let's check the Q&A sections. Any questions from the audience? I think there's a few.
Oh
Let's
my.
look at that. Okay. From a project planning point of view, what will be the biggest advantage of going the repeaterless? That's yeah, first question.
All right. Thanks, Isaac. So the biggest advantage. So if I were to choose only one advantage, right, it would definitely be the cost. So as we have seen a high level comparison between repeated and unrepeated, if we're talking about the CapEx and OpEx over 25 years, we're looking at 75% lower cost for your company. And if other than the biggest advantage of the cost, it is also faster deployment as we don't need to place any repeaters undersea. So that means faster RFS and faster revenue as well. So that those are the advantages of going repeaterless.
Okay. Here comes with a question on about ROPA. Can
Okay.
we add multiple ROPA to increase the reach?
Good question. I from from what I know, we have always only installed one ROPA. Maybe Isaac, you can add, but the ROPA, a fun fact is that it should be deployed during day one. So it means for a new cable, because if you were to add a ROPA on, say, an existing cable of a few years already, it's very it's kind of troublesome. It is definitely traffic affecting as you will need to pull up the fiber and install this undersea. So maybe Isaac, you want to add some to that question?
Now, I think you answered really good on that one. So the ROPA normally just put it at the middle of that at the edge of close to the cable landing station on that. Adding multiple on that one, it's not like because it's a Raman application. It's not like the wet plan type that you can just increase of doing that one. They have a function to boost the signal to the receiver side, right? So
Yeah.
that's a good question.
It's a good question. And I think, well, NPB is definitely working on improving their Raman solution. So perhaps we may see one of that in the future, but not today.
Okay, okay. Let's look at the time. Okay, what are the main factors that determine whether a cable should be repeated or re unrepeated?
Okay, good question. What are the main factors? So, if we're talking about trans-Pacific cable, like 10,000 kilometers, of course, the clear answer is you have to go repeaters, right? You have to have repeaters. So the main factors would be, of course, the distance, span loss, and your capacity requirement. So those are the main factors that we should consider when you're trying to design a cable, if it should have repeaters or not. So, for example, like mentioned, if you have a capacity requirement, say from Japan to US, which is well beyond 600 kilometers, thousands of kilometers, then of course you need repeaters. But if you have capacity requirement on segments that are less than 600 kilometers, then unrepeated cable would be one of the best options here. So factors are distance, span loss, and your capacity requirement.
Okay. I think there's another good question on the ROPA again. If we add the ROPA to extend the fiber reach, doesn't it become a similar configuration as like a repeaters? I think that's similar question that we had earlier. This ROPA is MPB. The Raman is different than the characteristics different than the one that from the repeater system. So I think that's not apple to apple comparison. Yeah.
Yeah, you're right. And even repeaters, we need additional like power feeding equipment at the CLS. Whereas ROPA, we don't need the additional power feeding equipment. Basically, it's powered up by the counter propagating Raman. So in other words, it does look like a repeater, but it's placed nearer to the receiving end of the site, and it doesn't need electrical power undersea. So it's
That's
a
good.
passive one. Yeah,
Very good one.
that's the difference. Okay.
Another questions on the capex figure. Okay, let me read it out here.
Okay.
The capex was on 100 kilometers, and you need more expensive equipment for the length. So how does the
Yeah.
capex increase when you go for 200, 300, 400 kilometers?
So in our comparison, right, I had to kind of standardize it to 100 kilometers. The reason why is because like repeated system, the repeater spacing is about 60 to 80 or even 100 kilometers. So hence why the comparison is based on 100 kilometers. However, it's not like, let's say if it's like 400 and you times 4. It's not like that, as the power feeding equipment is not multiplied by 4 if you have 4 repeaters. And it really depends. But for this high level comparison, we based it on the 100 kilometers basis due to the repeater spacing.
Yeah.
So
I,
I'm not sure if I answered the question.
I think
I help me out.
let's go back to the design questions. The 100 kilometers or whatever the kilometers you're talking about is the loss and also maintaining the OSN now end to end. So when you increase on that one, if you're doing amplification or you're doing the regeneration, for example, I think the capex increase, they're not in a linear fashion, right? So I want to highlight that we have done a lot of studies on different scenarios. I think this is could be another one example. We'd be happy to help you to any studies on that one. So you see the email attached on the screen. Feel free to contact us, and we can follow up with that. So another question is really popular. The I think it's also the robot again, the setup. Do we need to install the PFE in the dry portions or the optical pump modules alone sufficient? I think you answered
Um,
before.
no,
Yeah.
the answer is no. Yeah, we don't need it. So I think that's the main advantage, less power compared to repeaters.
Okay. Interesting. Another question. The roper
So many
supporting on.
questions.
Yeah,
Okay,
that's a
go
quite
ahead.
few. I think we have time.
Oh, sure.
On the roper supporting L-band as well as in the future to match the capacity.
Okay. Because yeah, as mentioned, MPB Raman only supports C-band today. So I know that with Ciena RLS and 6500, we can support CNL band. So in that case, unfortunately, it is limited only on C-band. So if you are going to use MPB Raman on the network with Ciena's photonics, that is capable for CNL. However, if you have an MPB Raman, it will only use the C-band today.
Yep. Yep.
Yeah.
So I guess that the point is when we go to the L-band with the MPB on that one, there's still a lot more studies and business case to build to make that
Yeah.
happen. Another questions related to the Ciena SRA. Transponder cost on the Ciena SRA and the MPB RAM in comparison page. Which one is more optimal?
In terms of cost, is it?
Yes, transponder cost.
Transponders cost. So if we were looking at maximum capacity, of course, with Ciena SRA, you need to use both CNL band. So in other words, if I can generalize it, it means you are using double of the transponders compared to MPB Raman of C band, and MPB Raman have higher line rate. So if we were to compare just transponders cost, then SRA Ciena's Raman would be on the higher side as you need more transponders. But if we take into account the overall cost, the Ciena Raman amplifier will still show an advantage in terms of cost per 100 gig, because you're getting more capacity out of your fiber with lower power, and the amplifier cost as well is lower. So I repeat, if we're just comparing transponders cost with Ciena SRA will be higher. But if we're comparing the overall cost, including transponders, photonics, power, then the unit cost per 100 gig with Ciena SRA will definitely be lower.
I think you have a really excellent presentation or material actually page talking about the OPEX and the CAPEX on that one, right? So one of the highlight on that is there's a trade-off between, is that the budget constraint, is that the capacity capability constraint on that one, and to try to find the optimum. But definitely by direct comparison, we can do a lot of comparison based on the different amplification solutions, which is good. I think we can answer more. I'll say one last question on that one before we close up the call. How do we decide? I think similar to earlier questions, how do we decide when to use a CNL band with a Ciena in-house Raman and the MPB Raman? What are the consideration?
Very good question. Um, I would say there is no direct answer like we need to use Sienna SRA all the time or MPB Raman all the time. There are trade-offs from the beginning of the design phase. We need to consider the costs, the reach that we need to cover, your capacity requirement. So in our real world example just now, when we use Sienna Raman amplifier, we have higher design capacity compared to MPB Raman, thanks to the CNL band. Of course, there's some cost implication as we have more transponders here. So capacity versus cost. So it really depends on what you're looking for. If you're looking for more capacity, then in this case, Ciena Raman amplifier would be the best way to go. However, if you do have more challenging unrepeated systems, so you're talking about span loss higher than 50 dB, so going up even to 70 dB, then the MPB Raman would be the recommended one, as it is a higher powered solution. So in Siena, we have experienced teams that have extensive knowledge and experience on unrepeated systems, on what amplifier works best for your system. So please feel free to reach out to any of us within Siena. We are happy to help you out with any network simulation or even to determine what right amplifier to use for your design.
Cost analysis on that one. So thank
Cost
you.
analysis. Oh, cost analysis. Yeah.
Yeah. So yeah, Christine, thank you. To the remaining, I think we can type it and reply in a later section on that one. So no more from okay, sorry, one more question. Last question on that one. So
Okay, go
if
for
we
it.
consider 1,000 kilometers hop, is there any significant savings or technical limitation on deploying the hybrid SRA and repeater options that uses less repeaters and less OpEx? You
Sorry,
can
wow, what a long question. Wait, so it's a 1,000 kilometers
on 1,000
unrepeated,
kilometers, yes, and well,
unrepeated.
it's a link requirement. So you're designing using Raman with
Okay.
the repeater options. Would that be using less repeaters or less OpEx? So you're basically mixing the repeaters with the SRA, right? So
Ah,
I would say if you're looking at that one, the answer is no. I
so
think
crazy. Okay.
again, when we're dealing with the design like that, we're looking at maintaining the OSNL and then on the bit rate and the performance, right? So you're mixing on the different photonic system on that one, but repeater is providing the constant gain, right? Total output power and the hybrid SRA or the MPB is today it providing it's on the sorry it's uh, uh, EDFA type of the gain, right? It's the different gain on it. One's the power, one is the uh, uh, per channel basis. It's different control mechanism on that. So I would say the answer is no. You're mixing the two on that one. The operation is different. But again, maintaining the OSNL is one of the key on that one. So um, less repeater and less CapEx. The answer is like no, it's not less repeaters. OpEx will be the same on the repeater system as well as on the SRA will be on the Raman amplification on that. So again, 1,000 kilometers is not about 1,000 kilometers. If the fiber loss is 0.16, for example, you're looking at 160 dB on that one, then definitely repeater system will be the key.
Yeah.
Okay, I hope I answer everything on that. And it comes to the end of the presentation. I want to thank everyone joining the call and thank you, Christine, to have these excellent presentations and materials. If anyone has any questions, please send through. We will make sure that we follow up with the answers for you. And with all that, I will want to thank everyone, and we can close the webinar for today. Thank you, everyone.